Today we will be speaking on power quality and I will be introducing the topic. The power quality definition states it is a manifestation in voltage, current and frequency deviation that result in failure or misoperation of customer equipment. That means the three parameters voltage, current and frequency, any variation in that has to be controlled so that we can ensure power quality. By IEEE definition, it says it's a concept of powering and grounding sensitive equipment in a manner suitable for operation of equipment. That means the utility will provide a clean power supply and it is the responsibility of the user to ensure that the system has got adequate protection so that it can be operated efficiently. The supply voltage quality is purely sinusoidal. Traditionally, we get a good power supply from power generation. The supply voltage quality is pure sinusoidal. Traditionally, the supply that we get is good. However, due to the faults that occur in the transmission optic distribution side or the lightning strikes or the non-linear loads which are added to the system creates a problem of power quality. Adding to that, we also have distributed generation which add new dynamics to it and heavy usage by the industry like arc furnaces, etc. and smart grid. Smart grid adds reliability to the supply, however, it doesn't do anything for power quality. The power quality can be broadly classified into the following parts, that is the transients, long-term voltage variations, short-term voltage variations, waveform distortion and voltage unbalances. Now coming to transients. The transients are of two types, oscillatory and momentary. Momentary are basically like lightning strikes, which is characterized by its sharp rise time, maybe nano/milliseconds, and fast decay time. And oscillatories are due to switching of capacitor banks or the reaction to the impulse created. They will have both positive and negative cycles and they will have a certain decay time. Voltage variations. Apart from over voltages and low voltages, which have got a duration of more than 1 minute, we have voltage sag and swell, which is characterized by a momentary rise / fall in voltage, and interruptions beyond 1 minute are called breakdowns. Now coming to harmonics. Any waveform which have been distorted can be constructed back using the fundamental frequency and various components of other odd and even frequencies. So a harmonic will have an integral multiple of fundamental frequency and odd and even harmonics. That is, a 50 Hz cycle will have a fundamental frequency which is called 1 and remaining up till 50 which are taken for fault calculations will have odd and even like 2, 3 and 4 etc. Then coming to phase sequence. All harmonic components will have positive sequence, negative sequence and zero sequence component. Positive sequence means it is in the same sequence as the system voltage or the three-phase supply. Negative sequence will have opposite reaction and can create negative torque. And zero sequence are the currents that flow through the neutral, which increase the neutral voltage or which circulates in the delta of a winding, which can lead to heating. The frequencies odd and even are as shown 2, 3, 4 etc. Apart from this, we have something called a DC notch. A distorted waveform may not be will have a certain asymmetry which will not be concluding at 0. That means it will have certain DC component which has to be offset and components of fundamental frequency plus harmonic component. Now coming to noise/notch. Notch is due to switching that takes place in our power electronic devices, and noise is the rapid switching like in inverters which cause certain noise of high frequency components. Now the harmonics in the system are characterized by their total harmonic distortion and total demand distortion. Total harmonic distortion is the responsibility of utility. It should ensure that we get a correct voltage which is free from distortions, and the limit set is approximately 5%. If the THD is high, then it will inject harmonic current into the system. So, a THD by the formula is the percentage of all components of harmonic frequencies by its fundamental frequency, that is in our case 50 Hz. This has to be kept as low as possible. Total demand distortion. Total demand distortion is characterized by the load in the system. So, it is all the sum of all harmonics divided by its load current. So, it is a end user requirement, and this has to be kept in control by the user. Now, power quality, since we have seen, now we will look at the solutions that are available. Coming to power quality solutions. Now, we can see the various problems that we face for power quality are power factor, which has been power quality solutions. Now, coming to power quality solutions. The various problems that we face are power factor correction, voltage variation, flickers, transients, harmonics, and swell/sag. For power factor, we can use capacitor banks, but during our discussion it has come out, they are also part of the problem. Similarly, the voltage variations can be corrected by using UPS or voltage stabilizer. However, they also inject harmonics into the system. Flickers, they can be smoothened out by using passive filters. Transients, they can be suppressed by using surge suppressors. Harmonics, we can use passive or active filters for doing the same. However, now we see we have got various solutions that are available which can do selective job. However, to combine power factor, the voltage variations, etc. with harmonics, we have to use dynamic voltage regulators or distribution static compensators or your UPFC. They can mitigate swell/sag and including harmonics in a very dynamic way. We have to use a combination of capacitor banks, passive and active filters, or capacitor bank, passive filters, and DVR for getting an efficient solution. So, summarizing, power quality issues are basically characterized by its frequency, amplitude, waveform, and symmetry. And the problems that we face are frequency deviations, and the problems that we face are frequency deviations, long-term voltage variations, voltage fluctuations, sag/swell, transients, harmonic distortions, and voltage imbalances. Thank you.